So this is Monday and Wednesday starting 11. So it's gonna be this one. Okay. Good. Wednesday 10:45 and 12:45. In this classroom, 2 hours exam. So it's not comprehensive exam. Any the topic that we have discussed after the midterm will be the final exam. Okay. I think the final exam will be easier than the midterm exam. So because we covered most of the topics on the database design in the midterm exam. And today we are going to continue the discussion on the query optimizer and the query processing. So last class we talked about the why do we need query processing and query optimizer. Overall, it's a query processing. So think about what happens when we submit the query. So when we submit the query, it's a select. So for example, this is a SQL. So when we submit the SQL, this is anyway high-level language, so it should be compiled. So SQL is a structured query language like the JavaScript. So this will be the interpreter. So interpreter will be used, but it's still the same as what compiler is doing. Like we parse, scanning, parsing, and validating. Scanning and parsing is to check the what is the keyword, whether the syntax is correct, and all the word, and check whether this. So this is what happened during the interpreter. And validating is we can check whether employee is using on the database and whether the user has the proper permission to access the data. After complete this one, this will be just like the object file when you compile the source code. So it's like the binary code is called the P code. P code will be stored at the server side. So server side also in the memory. So buffer, the P code will be stored. So this code will be used for the processing. Then the next one of the main job of the query processor is the optimizing. Optimizing means, as we discussed the last time, when we access, for example, this is the DPG and the workzone, and the SSN is equal to SSN, and the project ID is the same as the project ID. So when we have such the table join. So the query processor need to access the 3 tables in your database. So depending on the order of accessing the table, there are 3 factorial and factorial combination like the 6. And also when you join the 2 tables, there are different types of join. So like single loop join, nested loop join, the sort merge, and hash join that we are going to discuss today. So let's say there are 4 types of the join. So 4 times 4. And also for each table there are a variety of accessing methods to access each table. That we are going to talk the details, but we roughly check how many different ways to access such each table. Like the full table scan or primary index, secondary index. So let's say each one has 5 of them. So 5 times 5 times 5 times. So by multiplying all of this, so easily 2,000, 3,000 different ways to access the data in the database system. So we need to select only one optimizer, the method, one fastest, the route. So that is the main job of the query optimizer. So depending on how to select such a one, fastest one, there are 2 types of optimizer. One is the rule-based optimizer, another one is cost-based optimizer. Rule-based optimizer is like the rules when you purchase the ticket. So my rule is always the cheapest one. Next, convenient one. Next, the time, the travel time. So this is my rule. So when you search the internet or the Expedia.com or the TravelSuite, so cheapest one is the first. This is rule. But the cost-based optimizer is we will consider overall the performance, which means how much fast, how much efficient of each case, each 2,000 case. Check we can select the fastest one. So that is the cost-based optimizer, and that is the rule-based optimizer. So quickly, which one is better?
Depends.
It depends, but mostly we can say the cost-based optimizer is better than this one. However, it's a trade-off. To implement the cost-based optimizer, you need something information. For example, you need the review comment, and some of them already travel, the experience, and also all the information, weather and the travel time and the transit time and everything you need to collect. Then find the optimized one, based on the cost. Okay, so it will be overhead to collect such information. Also to calculate 2,000 different ways, it will take a long time to calculate all the costs. So cost-based optimizer is generally good, but it's a lot of overhead. So we need to reduce such overhead. There is one approach I will introduce today, very briefly, the heuristic approach. Heuristic approach, we will see how to reduce. Obvious case, sometimes private jet, we are not going to use the private jet. You can rule out obvious case, okay? Obviously not selected path. So then we will check some of them only. Then rule-based optimizer is we can just select a rule. So usually 10 to 15 rules. So like the full table scan, full table scan is the last one. Or linear search is a brute force. The fastest one, primary key. Using the primary index, we can access the data. That's the fastest approach. So we can apply such a rule. How do we decide? How does the optimizer decide? Check the whether in where close. Is there any primary key in the condition? Yes, then we select this one. There might be high probability to access the fastest using this one. Not always, but it's a rule. Okay. So this is a simple, but not always correct. So that is the difference between the CBO and IBO. Nowadays, the CBO is the suggested. Sometimes you may not know whether I'm using the CBO. But some of the DBMS, like Oracle, you can select either of them. But this one is suggested. However, this one, as I said, need the overhead. So like the statistics of the data, like how many tuple, how many data for each table, and even their distribution. Department number 1. And DNO2, DNO3. What is this? It's a histogram. Do you remember the histogram? When did you learn the histogram first time? Your elementary school. Do you remember probably you did in your classroom, elementary classroom, behind one time your teacher put something, the big paper. Then this is the cloud. And the cream, and the rain, snow, and this is how many times. Then every morning you put the note, right? Then this is cloud, this is rainy, this is the fine day, this is snow, and you can see the distribution of the weather for months or for a while. Okay, this is a histogram. This is also same thing, frequency, how often for each data. Then we can see the characteristic of the data using this histogram. This is the data distribution. You need to collect such information. Then, how do you collect such a statistical data for the table? You need to read the data using select. So it's really overhead. If you have the huge size of the database, like the 1 petabyte size data, you need to read the data. Also, how often? The latest one is better, right? but you cannot run the every time, real time. So periodically you need to refresh such a statistical information. That is one of the important job of the database administrator. You can automatically is doing that, but you need to think about the performance of your system and overhead of the such a collecting the statistical information. This is very critical. So sometimes when I'm using the CBO, you may not realize something problem first time. It's running very well. Course-based optimizer, the select the best, fastest the path to access the data. However, a year later, your statistical data is too old. Okay? It's not the current time. Currently, we have the millions of customers, but the year before, it was just 1,000 customers. So your course-based optimizer cannot consider the latest information. So it may route the different ways. So that is the problem of the course-based optimizer. For example, Oracle provides a command to collect the data, analyze. Analyze the command, if you run the analyze command and the database engine, check all the database and how many of them. It's really overhead. But you can do the sampling. Only the 5% of data access, then get such information. Okay, then once we got such a thing, so you can select the CBO. So then problem is what is a C? It's a course. What is a course in terms of performance here? Our goal is fast or slow, right? The fastest way to access data. Then there are a lot of the research that involved to read the data from the database. Memory, CPU, and network, and the bus, and there are a lot. Among them, most critical part of the research is the I/O. How many times read the data from the secondary storage? That is 99% of the overhead. So we just count number of I/O when you access the data. So for the 2,000 different cases, so we will count the first option. Take the 100 I/O. Second, 200. Third, the only one. For the million. Then we will select the lowest cost. Lowest cost means lowest the I/O will be selected. That is our goal. That is the goal of that is the way how the cost-based optimizer is working. Okay, so today we are going to see the different method of this one. Access the table. What is the different way of accessing the table? As if we are traveling to the New York City. How many different ways of traveling the Manhattan? Cab, or the bike, or the limo, or bus, and so on. So then what is the cost? Similarly, we will see the method 1, method 2, method 3 to access the table. What is the cost? Cost means number of I/O. We will calculate number of I/O. One more thing is join. So how many different ways to join two tables? As if we consider different ways of transition from New York to DC. Okay? New York to DC, so you can take the train, you can take the flight, you can drive, or you can the bike, and the different ways. Then their cost also. Then by combining all of this, so we will practice how CBO is working. This is a really good example and exercise. Later, when you tune your system, what does that mean? Tune up, make efficient, faster. Like when you tune up your car will be faster and high the mileage. Similarly, if you need to tune up your system when you manage the database, it's not only the database, but any system administrator, including network administrator, the Unix administrator, operating system administrator, also database administrator. Always think about how to tune up, how to massage, how to polish your system. At that time, there are two ways to tune up your system. One is system-wide tune-up. You can change something configuration. What is the size of the memory to be allocated for the database? and how many processes will be created, and what is the network bandwidth for that. So you can the system-wide tune-up. That is one thing you need to most of people know. Another the tuning is SQL tuning. So even though you have the perfect hardware infrastructure, but if the SQL is not the well developed, sometimes the query takes a day, 2 days. Supposed to be 1 second, but sometimes easily 2 days, 3 days. Okay. So who is in charge of such a SQL tuning? Actually, there is developer, but developer may not know everything. So usually administrator can suggest. So based on what? At that time you need to know how the query optimizer is processing, selecting that text. Then you can suggest you need to change the order of the table and so on. So that is the purpose of the practicing the query optimizer. So first, yes, any question? Okay. So then the first we will see what is the different method of accessing the data table. So to do that, so we are going to use I already hand out. So there is the notation. So number of record. So R is the small r is the number of record, and the blocking factor. What is the blocking factor? BFR. Average number of record in one block. Okay. Then we need to know block size. The capital letter B usually block size. Then we can calculate the blocking factor. And X means X is in case of the index usually have the level of that. So level determine what? Number of I when we search the data using the index. So level 1, 2, 3 is the X. That will be the number of I/O eventually. Then the large R is the record size. You cannot know exactly the record size of the all the database, all the table. Instead, it's an average because it's not fixed. It's a variable length. So it's always the average. How do we know the average? Even that is one of the jobs when you collect the information, calculate the average size of the length. And the BL1 number of the first level index block. What does it mean? In the secondary index, B3 index, when you access the data sequentially, it's a range query. Like for example, in this case, the ID is bigger than 1. First, you need to find the 1. Then you can use the sibling pointer. You don't have to up and down, 1, 2, 3, 4, 5, 6. So first level, leaf level node, how many nodes you have? That is the BL1. First level leaf node block. D is the number of distinct value, which means how many unique value in your table. In case of a primary key, it's the same as the number of record. However, for example, DNO in the employee, it will be less than the number of employee. Okay, but the unique, the value. Then selectivity is this one. Distribution. At the DNO in employee, 20% is the D number 1, 50% is the D number 2, 30% is the D number 3. So selectivity is the probability of it's a kind of portion ratio of the data in the table. Then S is the selection cardinality. Then if we, for example, we have the 100 the employee. How many department number 1? 20, 50, 30. How many? 20. You can multiply. Okay? The selective, so S is the selection cardinality. Actually, how many data will be returned? And SL times I, which means the portion, probability, distribution, portion multiplied by the number of record. That makes sense, right? So then, how do we get such information like the selectivity and everything? You need to collect all the statistical data. However, keep in mind, it doesn't have to be exact value, real value. It's a statistic. So it will be based on the sampling. So database will the investigate only the 5% of your data, then calculate this one. Like during the presidential campaign in the United States, there are a lot of polls. Which one will be president, like the Clinton, Hillary Clinton, or the Donald Trump? But they do not ask all the voters in the United States. Only 1,000 or 2,000, right? Then they guess, estimate the 51% or the 49%, something like that. Similarly, DBMS do not collect all the information. Instead, some of the part of information, then the estimate this information. So keep the latest information about this one is very critical in the CPU. Then we are ready. First, why don't you take a look at the column 1? You can see the S1, S2, S3, S4, S5, 6, 7, 8. There are a lot. Actually, more than that. Okay? We will see how many different types of accessing the table first. Then we will see the cost, calculate the cost. The first one, linear search means, linear search is a brute force way. Read each and every data. And second, if data file, table is ordered, you can use binary search, right? When data is ordered, we can use the binary search. Everybody knows what is a binary search. I don't have to explain again here. Then the primary index. So S1 and S2, do you need the index? No, we don't need the index. Only the data file, only. But the S from S3, it needs index. So do you remember the primary index? Primary index is you have the data file. Data file consists of what? Number of blocks. Then they are ordered by the primary key, SSN. Then when you have the primary index is the first row and pointer this. And second from the second block, first row and point. And so on. This is called the anchor, the representative row of the block. So we can take only one record per block from the table, then make the index. That is the primary index. It's non-dense index because we select only one record per block. Okay. At the time, that is called the primary index. We are not going to see the hash index because hashes, there are variety. You need to consider the variation, like how many hash key, hash bucket size, and and also the inside the hash, whether you have the hash of hash. So very complicated. So for the simplification, we are not going to consider the hash this time. The next one is the primary index, but it will be different. If we access only one record, find this one, then going to this. However, in case the range query using primary index, once you find this one, you need to range query. So range query of the primary index, that is the S4. S5 is a clustering index. Do you remember what is a clustering index? Like the index for DNO. It's a cluster. It's a non-dense index, right? But it's a point, the group of the data. Data file is ordered by the group, the DNO. For the employee table, for example. And S6 is the mostly used one. It's a secondary index. What is the most popular secondary index? It's not ordered by that column, but we need. It's a surrogate key. We can use that surrogate key or the primary key for the secondary key index. Then what is the indexing structure? Mostly used for the secondary index. So by the bit plus or the bit tree index. Okay? So B3 index, we will consider all the record. They don't have to the sorted. If already sorted, we can use the primary index or the other index. But in case non-sorted, but we need to make the index, we can use the B3 index or B plus 3 index. So in our case, we are going to use a B plus 3 index. So B3 index is the special case of the B plus 3 index. So we will use the B plus 3 index for the secondary. S7 and S8 is not always the query is like this one, clear. So SSN is something, and sometimes DNO is something. This one has the key, this one has the key, the index. Sometimes composite index we can have. So in case multiple cases, that is the conjunctive, the selection, we can consider the either of them, that previous one, conjunctive. In case you have the composite, we will directly use. So we will see that each of them, the cost. That is our goal, to calculate the cost. So first one is a linear search. What is the cost? Our goal is to count number of IO. IO here, what is the IO unit? Keep in mind the block, always block. In computer, any computer science subject, when we talk about the IO, IO means the performance of the IO, cost of the IO is based on the block. However, different block size. So in this case, the block is the B, number of block. So what is the cost of the linear search? We have the table like this one. So we have the table like this. This is a table information. Okay. Then using the linear search. Linear search is the brute force way. You need to check the sequentially. All the record. No, you don't have to check all the record. All the blocks. So how long it takes? How many? In other words, how many IOs? L. N. Number of record. I already mentioned. Not the record. We are going to count number of blocks. Always block. That is the IO unit. So how many blocks in this case? How many blocks? It's a B. B is the number of blocks. It's not here, though you can calculate using the blocking factor. B is the number of blocks. However, if you are lucky, you can find your data from the first block. Right? Then do we need to read the next block? No. So if you are lucky, it's the first one. But if you are not lucky, like me, you will read all the blocks. How many blocks? B. So on average, B over 2. So that is the reason, the B over 2. However, sometimes if we do not consider such as the average, we can just consider as the B. But in our case, it's a B over 2. Somebody said, why not? B plus 1 over 2. B plus, we don't have to, okay? This is just the statistics. The B over 2 is the average half of the record, okay? Because some of the students, so first and the last, the B plus 1, but we don't have to do that. So B over 2. Binary search. So in case the data table is sorted, okay, we can use the binary. So in this case, it's not sorted. We brute force way. But in case it's sorted, we can use the binary search. What is the complexity in terms of big O notation? What is the complexity of the binary search? Log n based on 2. So in this case, log b, because we have the b number of blocks. Then, so that's this one. Okay. However, what if this is the data file block? Then we are going to use the binary search. Binary search means cut in half and check. Cut in half, cut in half. So to find the block, that include the data is how long it takes? Log B based on 2. This is the number of I/O you need to search this one. If that equality, then that's it. So that is the reason log B based on 2. However, if that is the inequality, bigger than this, you need to read next, next, next until the end. Okay, how many? So that is here S. How many data? Okay, S. If that is not unique, so you need to read the data. S is what? Selection cardinality. Okay, for example, in case it's ordered by the DNO, it's a clustering index. So I'd like to read the 1. So in this case, it's equality. DNO is equal to 1. So we found that DNO is equal to 1, and this is 1, this is 1, 1, 1, 1, 1, 1, 1, 1. Okay? How many blocks? 3 blocks, for example. So 3 blocks, that is the S, selection cardinality. Selection cardinality is how many tuples for each value. Okay? Then, but this is the number of the record we need to divide by blocking factor. What is the blocking factor? Number of record per block, because our goal is to count the number of blocks. So it's divided by the blocking factor. Then it's a mistake. S. This one or this one? Ceiling or flooring? Flooring. No, ceiling. Because even though it's one record, you need to read the block. Okay? So you need to ceiling. So that is actually ceiling. Okay? So it's a small mistake. Then, what is a minus 1?
When we are selecting data file, we don't need to go to
First, we select this one. First block. It's already counted. So we don't have to count this one again. So minus 1. So that is this. In case S equal to 1, that is the first case, this one. S equal 1. 1 over buffering factor is bigger than 1 usually. So this is 1 minus 1. It's the same as this. So this is the I/O, number of I/O in case binary search. Okay? Then, primary index, this one. Don't worry about the hash. The primary index. In case of primary index, so this is a block and we have the index. So multi-level index, yes, we can build a multi-level index. Okay, so if level is X, how many I/O do you need? 1, 2, 3, plus 1. Do you remember when we talk about the indexing structure? Always plus 1 to access. When you use the index, you need to plus 1. So level plus 1, level plus 1 is this one. What about this? Multiple record. For example, if you are accessing bigger than 1, which means 1, 2, 3, plus 1, you select this. Then it's a range query. If you are lucky, 1. If you are not lucky, B. So it's a B over 2 on average. Okay, so that is the reason X plus the B over 2. We will see the real example later. Okay. Next, the clustering index. Clustering index is the same idea. Okay. First, we need to count the level.